Next is there are different factors that affect the soil structure. Soil structure can be influenced by many factors like climate. If there is a heavy rain, if there is an increase of temperature, if there is a high rainfall or high temperature, then the soil structure is changed. If there is a high content of organic matter, then the soil structure is changed. If there is a tillage operation, the tillage operation breaks the soil structure is changed. By roots of the plant, by animals, by microbe decompose soil particles. This the microbe also can change the soil structure. Even the application of fertilizer, even the wetting and drying of soil can change the soil structure. These factors influence the structure of the soil. The next physical property is soil consistency. Soil consistency is nothing but it's an resistance of the soil. It's a resistance of the soil. If there is a soil, it is a resistance of the soil to the stresses. It's the resistance of the soils to the different stresses in a various moisture contents. Various moisture content means when the soil is dry, when the soil is moist, when the soil is dry. Under these contents, how soil resistance are different types of stresses. That's what the soil consistency is. I hope you get the point. The soil consistency it combines both cohesive and adhesive properties. Cohesive properties means it's an force attraction force between the two soil particles. Means it's also soil particle, it is also a soil particle. It's an attraction force between these two same particles. Adhesive, in case of adhesive, see for example, this is a soil particle, this is a root of the plant. It's a force between these two different particles. This is a soil particle, this is a root. So it's an attraction between these two. This is called an adhesive and this is called an cohesive. So it combines both. Consistency is combination of both cohesive and adhesive forces. See, in the soil consistency is described at three moisture level, that is wet, moist and dry. The next property is the soil plasticity and the cohesion. The soil plasticity is capacity of the soil to change its shape under the different moisture conditions. If there is a soil, we can change this soil shape into different, like we can make like this, we can make like this. So we are changing the soil shape under different moisture condition. Different moisture condition means these are the different moisture condition. That is wet, when it wet we can change, if it is moist we can change. So like this, it's a capacity of the soil to change its shape under the different moisture conditions. See, if the soil is cohesive means it can be it has a plasticity property. The plastic soil have cohesive. If the soil are cohesive, if the soil particles are binding with each other, then only plasticity is possible. The soil is binding together, then only plasticity is possible, right? And the next one is soil contains at least, if the soil contains at least 15% of clay, it will have the plasticity property. Minimum 15% of clay is required for the soil to become a to have this plasticity property. I hope you got these physical properties. Next we will discuss about the bulk density and the particle density of soil. So what is the definition of density? Density is nothing but mass by volume. You already know it. Mass by volume. Sorry, excuse me for this. What's happening? So the density is nothing but its mass by volume, right? So the mass is measured in gram and the volume is measured in centimeter square. There is something change. Let me check. Excuse me, friends, for the disturbance. Please don't mind. There was some change in the settings. So now we will resume. The density is nothing but its mass by volume, right? Again, there is some change. Let me get back to you. Okay, we will resume now. The density is nothing but mass by volume. Mass is measured in gram and the volume is measured in centimeter square or meter cube. So it is the density, the unit of density is gram per cc. See, you can see the image here. There are two containers containing some soil particles. See, this having the lower bulk density because lot of space is there, and it is having higher bulk density because it is compressed and there is no much pore space. The pore space is higher here and the less here. Obviously, the soil strength will be more here and the less here. So there are two types of densities we will discuss here. There are two types. One is particle density, one is bulk density. This particle density is also called as true density or apparent density. It is also called as true density or the apparent density. In particle density, what we measure here is by the word particle itself, we can assume that it's a density of only particles or solids. It's a density of only solids because it's a particle density. That's why it is we consider here the density of solids. It's only. So it's a mass by volume, right? So it's a mass of soil solids divided by volume of soil solids. That's what the particle density is. Here pore spaces are excluded. Pore spaces are excluded here because we are considering only particles. So we are excluding pore spaces here. Usually the particle density of a normal soil is 2.65 gram per cc. The next one is bulk density. The bulk density is also called as apparent specific gravity. The particle density was called as apparent density, but the bulk density was called as apparent specific gravity. And here we take the oven dried soil, oven dried soil, and we measure the density of this. So the density is mass by volume. So we consider, we take the mass of oven dried soil divided by the volume of oven dried soil. So here in case of volume, we are considering both solid, the volume of solid as well as the volume of pore space. It's a difference here. We are considering the volume of solid as well as pore space. In case of particle density, where we were considering only the volume of soil solids, not the pore space. So here pore spaces are included. In case of particle density, pore spaces are excluded. In case of bulk density, pore spaces are included. Pore spaces are excluded, pore spaces are included. Usually, the bulk density of soil, is half of the particle density. So the bulk density of normal soil is 1.6 gram per cc, whereas in case of particle density is 2.65. It varies. Okay, there is a range. In case of particle density, we can say that the range of particle density of different soil ranges from 2.6 to 2.8 gram per cc. In case of bulk density, the bulk density of different soils varies from 1 to 1.6 gram per cc. You remember this range. If it is between 1 to 1.6, it is a bulk density. If it is between 2.6 to 2.8 gram per cc, it is a particle density. Okay, I have already discussed this. See, the particle density is nothing but true density or the apparent density, whereas the bulk density is apparent specific gravity. Here we take the mass of soil, volume of soil solids. Here we take the mass or weight of oven dried soil and the volume of oven dried soil. The next one is porosity. Porosity is nothing but the space that is divide of solids. There is no solid here. There is only it's so wide. It's filled with air. So the space is free of solid. That is a porous soil. The porosity of soil increase by the adding of organic matter. If we add organic matter, there will be increase of porosity. So the clay having the 50 to 60% of porosity, because it contains micropores, lot of micropores. In case of loamy soil, clay loam, the 30 to 50% of porosity will be there. Clay having the maximum percentage of porosity, whereas the sand having the lowest level of porosity, that is 30 to 20 to 30%. Sorry, among these three, I'm telling. Okay. See, and the porosity also depends on what crop we are growing. If you are growing some grasses like blue grass, grasses, then the porosity will be increased eventually. The virgin soils having the more pore space, and the continuous cropping reduces the pore space because we are breaking the soil aggregates more frequently. The soil texture is changing, That's why the pore spaces also changes. We are reducing it, we are breaking it. So when we can say the pore is if there is a pore, if there is a wide space, when we can say it's a macro, and when we can say it is a micro. If the diameter of the pore, for example, this is a pore. If the diameter is more than 0.05 mm, then it is macro pore. If the diameter of the pore is less than 0.05 mm, then it is micropore. Macropore and the micropore. See, here is a porosity. We can see here the sand having macropores. Macropores. Because of the macropores, the water retention capacity reduces because there will be a lot of drainage. That's why there is no water retention capacity, and the water gets drained because of the gravity. The silt is having different kinds of macropores as well as micropores. Whereas in case of clay, there are a lot of micropores, so there will be higher water retention capacity, less drainage. So the maximum number of micropores having clay having a maximum number of micropores having a you know high water holding capacity and the low drainage. See, it is a combination of sand, silt, and clay. We can see the micropore and the macropore and the micropores. The porosity matters for the water holding capacity. They are interlinked. They are interlinked. The next one is soil color. We have different kinds of soil. Soil color changes due to various factors. If the soil is having some color that indicates the soil features, means the soil is red. For example, the soil is red. It came from the some of the red color minerals. So the change in soil color from adjacent soil indicates the difference in the soil mineral origin. If the soil is red, means its origin, its a source is having some red color mineral. So we can say we can there are different kinds of soil. We can differentiate those soil based on there is a Munsell chart developed by the scientist Munsell. There is a Munsell chart. Based on that, we differentiate different kinds of soil, different soils of kinds of soil colors. So the Munsell color system. This is called a Munsell color system. There are mainly three factors in the Munsell color system. Three factors in the sense there are three components of Munsell called color system. Munsell color system. The components are: one is hue, second one is value, third one is chroma. You can see here the hue is this part. The hue is this part. The hue is nothing but it's a dominant colors. These are the dominant spectral colors. Dominant spectral colors, it can be red, it can be yellow, it can be blue. These are the dominant spectral colors. Here we can see green, here we can see yellow, red, yellow. So the hue represents dominant spectral color, whereas value, this is the value, this is the value here. Value represents lightness or the darkness of the color. lightness or darkness of color. See here, the 10 represents white, means it is very light. The 0 represents it's a dark. So the value represents the lightness or the darkness of the particular color. Then the third one is chroma. This is the chroma. The chroma represents purity of color. Purity. Sorry for the bad handwriting. You can see this PDF. You can refer this PDF for the more clear sentences. The chroma represents purity of colors. Or the strength of colors. How much pure is the color? See, these are the blue only, but there are different kinds of blue. So remember these three terms: hue, value, and chroma. And remember the scale also. The value scale is from 0 to 10. See here, it's already given here. The hue represents the dominant spectral color, that is red, yellow, or blue or green. Value represents lightness or the darkness of the color. It ranges from the 0 to 10. Chroma represents the purity of color or the strength of the color.